Hello students, this is lesson U6A01c. By the end of the lesson, you should be able to say I can perform composition of similarity transformations. Okay, so let's discuss what exactly is a similarity transformation. Okay, so this is the first time that I'm using the word similarity. We've used the word transformation in the past. Okay, transformation is basically we're changing the original object, okay, and creating an image, okay, from that original object, either by translation, rotation, or a reflection. So here in a similarity transformation, it is just a composition of one or more rigid motions plus a dilation. Recall what a rigid motion was again? Rigid motion, again, is simply just a translation, reflection, or a rotation. But now, with a dilation added on, we're calling this a similarity transformation. Why the distinction here? Well, that's because a dilation is no longer a rigid motion. The object is no longer going to be congruent. And why are we using the word similar? Well, that's because the object after the dilation is not congruent. However, all the proportions, all the sides are going to be of the same proportions. So because all the sides are going to be proportional, we refer to this observation as similar. Okay, so the objects are said to be similar, but they are not congruent. Okay. So two figures are similar if there is a similarity transformation that maps one to the other. A circle, for instance, all circles are actually similar to one another because all circles are going to be proportional regardless, right? What are rigid motions again? One more time. So again, rigid motion is any way of moving a figure such that lengths and angles remain the same. And there are four types of rigid motions, remember? There's a translation, rotation, reflection, and guide reflection. Now, any transformation involving dilations is not a rigid motion, so a similarity transformation is not a rigid motion. Let's take a look at this example here. Is this a rigid motion or a similarity transformation? Describe the type of transformation that has taken place to go from ABC to WXY. So if you look at this, okay, it looks like there's pause the video to see if you can articulate for yourself. So if you look at this, ABC and WXY is definitely not oriented in the same manner. Okay, so there most definitely is going to be a rotation of some kind happening. So yeah, it is a rigid motion. This is going to be a rigid motion. And the rotation can be found by doing something like this. Is this a rigid motion or similarity transformation? And describe the types of transformation that has taken place to go from ABC to WXY. In the last example, I wasn't as clear, but if you do, for these types of questions where they're asking you how we go from one figure to another, where it's not on a coordinate grid, and even though I am drawing this on on graph paper, you just need to simply describe what's happening here, okay? So pause the video to see if you can describe how are we going from ABC to WXY. If you're thinking that this is actually a glide reflection, then you're absolutely right. This is in fact a rigid motion. This is a glide reflection or glide translation. Okay, is this a rigid motion or a similarity transformation, and how do you know? All right, so here in this case, okay, we're going from ABC to WXY. How are we going from ABC to WXY? Pause the video to see if you can figure out what's happening here. So welcome back. Hopefully you guys had a chance to think about this. This is actually going to be a rotation and a reflection. So if you think about this, this one is definitely more challenging. But the transformation that we can undergo, going from ABC to WXY, we can perform a rotation first. And then after we perform the rotation, We can then perform a reflection. How do we go from ABC to WXY? Is this a rigid motion? Pause the video and see if you can answer the question. So upon inspection here, ABC to WXY, they're not even the same size, so absolutely not. This is not a rigid motion. However, how do we go from ABC to WXY? It looks like there's going to be a reflection happening, and then after a reflection, perhaps a dilation. So we're going to reflect, and then we'll dilate. All right. Is this a rigid motion, going from ABC to WXY? And again, this is not a rigid motion because we are seeing that the size of the triangles are different. Now, what are you going to do to go from ABC to WXY? Pause the video to see if you can figure this out. So hopefully you had some time to think about this. How do we go from ABC to WXY? It looks like there's definitely going to be a reflection, and then from the reflection, a rotation to get in that kind of orientation, and then finally a dilation. Again, this one was definitely more challenging than the others. Alright, so let's perform the following similarity transformation on triangle ABC, and then we're going to try and graph out what the image is after the 4 transformations here. So we're going to, if you have graph paper handy, it would be a good idea to plot triangle ABC. Pause the video to see if you can figure this out on your own first. So welcome back. Hopefully you had some time to think about this. We're going to translate triangle ABC by in the direction of -5, -3. So A prime, B prime, C prime will end up in the 3rd quadrant. We're going to reflect this over the line y equal to 0, which is basically the x-axis, so we're going to reflect it. And then finally, we're going to rotate this -90 degrees. So -90 degrees means we are going to go clockwise, so it's going to end back up in the 1st quadrant. And after we end up in the 1st quadrant there with a rotation of -90 degrees, we are going to dilate this over the point -2, 6 by a factor of 2. So I'm going to pinpoint -2, 6, and then we're going to dilate it by a factor of 2. So A to the 4th, B to the 4th, C to the 4th will end up with the coordinates of 4, 2, 2, 0, and 6, -4.